Others will be just standalone. But we're going to use the next 2 weeks to give you just a brief on the other two supporting languages. I believe that the IEC 601131, which is the programming language standards for controllers, has 5 programming languages that are established. And so we're going to be touching on at least 3 of those with this next 2 sessions. And what I like to do is just make it practical. And we're going to do exactly what we did when we started, using function block diagram programming. And so let me see, I'm going to do a better focus here if I can, for recording purposes. That way you guys can see, and anyone reviewing could also see. There you go. Okay, so that's a good check. So let's start a brand new program. If you guys are there, and we can call this logic FBD. So we're creating a brand new project, and we'll call that logic FBD. And we can use the simulation controller here, since we're not connected. We're using the simulation controller. Adding that to the project. You guys know by this time that you can switch controllers back and forth. That's not a problem. No one else is online. That's okay. And we're going to start a brand new program. Right-clicking on programs and adding a brand new FBC or FBD function block diagram, right? So and there's a default name that those programs are going to come with. And the default name is program 1. So there it is. I'm going to open that, and what I got is just a blank screen, right? That's just the prep. I'm going to wait for you guys until you're there so we can all dig in. Let me know when you're there. So that's the blank canvas that you get to start doing function block program. But it should be there for you. There's the toolbox under view, actually, is where it appears.
There's another one over there by
what was
the
that?
wrench. There's another one over there by the wrench.
Yeah, so yeah, there should be a number of ways and icons by the wrench on the right hand side, right here. Yeah, there you go. Yeah. Okay, so you have it there. You can just open the toolbox. And let's start with the first block. So we just bring a block. It's a general block. Okay, and then it takes you to the search box. And if you just do not, which is the basic logic negation, right? You can just click on the not, okay it, and we have defined the not function in function block diagram. Now, there's a few nice things here for documenting your project. You can do comments, you can do labels, and things like that on this project. So a comment is basically just a little bar like this one. And then you double click and you say, this is the FBD for the logic not. And you can
So the not was an instruction block? Is that what that was?
Yes. So you can actually document your things here by using any formal notation that you want. So there's the not instruction. You know, of course, we need some IOs on that not, right? So that it does what it's supposed to do. And I go back to the toolbars, and what I need is variables. IOs are considered variables. So I'm gonna bring that variable label to the back or to the front. And it will take me to the local variables or global variables where I can select my inputs and my outputs. So I'm gonna do input 0 for this one. And you can label that just like you've done before, right? You can call that input A or whatever, the alias. Okay, and then we're gonna do the same for the output. And we can call that output A, if you will. Whatever label is the bracket, you're gonna label it. And notice that these things connect automatically, not all the time, but they do. So there is our very first function block form that has basically 3 instructions: the input variable, the output variable, and the logic statement. Okay, and you're gonna have to compile and download just like the other ones.
Is the green thing just a comment?
That's just a comment.
Oh.
Yeah, just a comment back. Okay, so comment. I'm sure you can change the text size and the color and all that stuff. All right, so let's go ahead and download this. And however you want to download that, I'm gonna go to device and download. And of course, you have to have your controller turned on. I don't think I have it, so it's not gonna download. It says successful. Oh, there you go. So we need to select the controller, which is something you already know. We're using the simulation controller. And mine is just hanging in there. So the thing is looking for some place where it can be deployed, just like before. But it's funny that it's not letting me select. Oh, I know why. I'm crazy, right? Yeah, remember you have to have your controller running before you can do this. So cancel if I can. Yeah, I forgot to turn on my simulator, and that's the boundaries here. So I'm gonna close that and open the simulator. Here's the simulator. Turn that baby on, and I should be safe if I download. So download this time, and the simulator should be selectable. There we go. All right, so I'm downloading that NOT gate. Takes a little bit to download, but it should be there. There we go. And now you can read your, notice that this one is already, it's already functioning. So if I switch over to program mode, by default, the output is on, right? Just like it should be. If I turn over input 0, the output goes through, right? It's doing exactly what it's supposed to do. By default is active, because that's what the NOT gate does, right? It takes the signal and converts it to the reverse operation. You can monitor that right there. You find it, you might find,
No, not here. I'm just finding there. Yeah.
all right. Okay, we're gonna do the second one for you. Just make sure you pump up your Allen Bradley. Okay, let's go ahead and stop here. And since we're just having fun, we're gonna build everything in a single canvas here. I find that when you have multiple programs, you have to keep an eye on your logic. So let's go offline, disconnect, and do the next one. All right, we're gonna do a logical, another logical statement. I'm gonna call this the AND gate or the AND logic. So there's my AND, Boolean AND. Okay, same block of instructions. I now want to say that you can label this too, just like we did before. So this is the FBD for the logic and gate. Okay, so that's the logic and gate. And of course, when they're variables. So what I normally do, guys, when I use the same canvas or screen to do multiple programs, I try not to repeat the IOs, right, on my thing. And this is what we're gonna be doing here. So I'm gonna use different IOs. So I need 3 variables. Okay, so I'm gonna bring the variables. Right, I need an output. You might pick up that computer with the software we're learning about function block pyramid, and you can just get on board as you go. All right, and I'm gonna use actually I want to use output B for this one. I'm gonna call that output B just for the sake of putting labels on my things. I'm gonna add a couple more variables because I need to do so. And again, I try not to repeat this input so that I don't mess up the program, right? So that's gonna be input B. And of course, I need another variable because this is a 2 instruction logic gate. And I'm gonna call this input C, if you will. Okay, so we can just connect by click. You can move these elements around, organize them however you want them. And we have built the AND function block firm, if you will, one single instruction firm. All right, so that is the logic AND. Let's go ahead and download. So just a little heads up, the assignment for this week, we're just doing the tutorial now, is gonna be converting a given ladder program into a function block equivalent, right? And just for your reference, it's gonna be on page 97. It's actually a schematic that it's part of the problems in the book. So 560 is that you're gonna take and you're gonna convert that into an actual function block program. 560, I think I did send an announcement on that, but okay, so this is good to go. I'm gonna bring my simulator and check this up. Put it in run mode. I don't care about input 0 and output 0 this time because that's the NOT gate. I am testing the second, right? So input 1 is on and output 1 is still off. Input 1 and 2 are on and output 1 is on, right? Which is how it should work, right? It's doing exactly what it's supposed to do. So there is our AND gate functioning as it's supposed to function. Right? When both are true, the output is true. When any is not true, the output is false. All right, so we have done the second one, popular AND junction. All right, and this all combined together to form various complex circuits. Okay, since Ezra and Zach are on board, let's do the next one. I will call my toolbox. I'm going to bring a instruction block. Okay, I'm going to call the OR gate. So OR logical is what I want. And then I'm going to label this thing. Actually, there's a comment what I do. So I'm commenting the function block. And this is the FBD for the logic board. This is the FBD function block diagram for the logic function board. All right, again, I don't want to reuse my inputs and outputs. So I'm going to pick up different variable names for the OR gate. So back to the toolbar, variable, place it over, just click and drag. And I'm going to use output 02, which I'm going to call that output C. So that's my output C. I'm going to bring variables into the input. And since I'm already using the first three inputs, I'm going to use the next one. I'm going to call this input D, just to say something. And to make sure that I have completely different variables so that I'm not having difficulties to interpret what's going on. I'm going to call that input E. And notice again that these guys connect automatically. Usually is the case when they're in close proximity. If they're a little bit apart, you have to do the connection, right? But typically, they will connect. And you can move things around. All right, let's go ahead and download it. And I need to be in program mode. Download.